It's a little squished, but it should be fine. Cool. So I wanted to start on an interactive note. So who here, what do you guys think? What's the most common chain out there when it comes to daily active addresses? Any guesses? Everyone guessed Tron already? Come on, at least like throw in a few, I don't know, other chains. Okay, the answer is Tron. It is true. If you believe the numbers by token terminal, obviously it's hard to know. Unique users, unique addresses. It's hard to differentiate between them, but assuming that these numbers are true, then they are way, way ahead. And I don't know about you, but that makes me a little sad. Because I'm here in Istanbul, to think about scaling Ethereum, and it's a little sucky that Ethereum is not number one. There's others that have noticed. Anthony Sassano recently tweeted, that Tron is, by far the biggest chain when it comes to payments. It's offering real value to real people. Those are some pretty strong words. And it's true, a lot of people, I think half of all USDT in circulation is on Tron. There's just a ton of payment activity happening worldwide on Tron. And I don't know about you, but that makes me a little sad because this is the future that I want for Ethereum, right? Everyone rushing into the house of Ethereum. And instead, this is the reality we have today. Just a few of us here in this conference room here in Istanbul having all of the fun in what looks like a about to go bankrupt Bed Bath & Beyond. We know this. We're working on a solution collectively together, right? In the future, L2 gas fees will be low in Ethereum. We've got proto-dank sharding around the corner. You've got dank sharding coming. But, this will take a while. Vitalik wrote this really interesting blog post recently. Who's read the blog post? Got a few hands up. I'm really struggling with this mic here. In the post he talked about, now it's just broken. I might have to hold this like a TikTok star. In the post, he talked about a couple of things. He talked about the fact that number one, perfect. And not everyone, not every chain, not every use case needs Ethereum level security, number one. But number two, there are some L1s that are thinking about transitioning to L2s and waiting until dank sharding gets released effectively limits their ability to transition, limits kind of the momentum that they may have today. And that speaks to me because I'm working on Celo, which is one such chain, which is working really hard right now to transition from an L1 to an L2, rolling up to Ethereum. And we, don't want to wait, for dank sharding as much as we are excited about what dank sharding will offer. And so, for those of you who maybe aren't familiar with Celo, just to get everyone on the same page, Celo is an EVM L1 that's transitioning to an L2. We're really focused on ease of use. On those same use cases, I would say that Tron maybe is excelling at. Payments, microfinance, mobile DeFi. And we're doing this through really great mobile support. So you can, on Celo, there's a ZK Snark that you can run on mobile phone to sync with the chain really efficiently. You can also send payments to phone numbers on Celo, which in a privacy-preserving manner, which is really, really nice. And then you can also pay for gas with tokens on Celo. So if you want to send a payment to someone in a stable coin, you can pay for that transaction fee in that stable coin. And you can do this today without account abstraction with EOAs. We also happen to be the first chain to offset its carbon. It's just a small cherry on top. But all of this has translated into a lot of utility in this bear market. People focus on real-world use cases, don't really care about bear markets. And so in the last year, we've seen a lot of growth, which is really great. And coming back to this chart, we're a top 10 chain here. Not as high as Tron, obviously, but it's really nice to have made it into the top 10. And this isn't just thanks to the efforts of the folks working on the platform, but really it's the dApps built on top of Celo that are driving this. One such dApp that might interest you is MiniPay. Who here has heard of Opera? They are around still. They used to have a really great desktop browser. Now they're focused really on mobile, and they have this browser called Opera Mini that has 500 million downloads, 100 million users, and they just recently launched a stablecoin-focused wallet built on top of Celo, leverages all those features I talked about, and they're rolling it out to try to become kind of a Pan-Africa Venmo. So it's really cool. There's another wallet called Valora that I work for that's very similar. Again, it uses all of the Celo features. And so if you have friends for whom MetaMask is too confusing, would highly recommend trying out Valora. Okay. And so now we're all on the same page about Celo. And so you can start imagining, what are some of the requirements that Celo has as it's thinking about transitioning to a layer 2. In prior talks, maybe you've heard me talk about decentralized sequencing, about one-block finality. One additional requirement that I'm going to talk about here is around gas fees. For the kinds of use cases that we have, it's pretty critical for us to maintain really low gas fees. And so, not surprisingly, that kind of necessitated that we went out and looked for alternatives to, bank sharding, which is very, very far in the future. We wanted to find Ethereum-aligned alternatives available today or, coming soon. So not surprisingly, we came across EigenLayer and, of course, EigenDA. And we're really fortunate to have been granted I would say, a sneak peek into EigenDA in the last week or two. And we have actually integrated the Celo testnet, L2 testnet based on OP-Stack has, as of last few days, actually integrated with the latest EigenDA kind of preview. And we're super excited. And here's a screenshot of a OP-Stack batcher that is actively writing to EigenDA blobs, again, using kind of the preview test code. So a lot of people have, been curious, like what's been our experience doing this? And the answer has been, resoundingly positive. The integration took, honestly, less than 48 hours. This is in large part because the EigenLayer team had, a wonderful POC that we were able to work with and look at in order to write our code. It took less than 1,000 lines of code to modify our version of the OP-Stack code base, and just as a little sneak peek of what might be possible, just running on a single simple laptop with 10 cores and 4 EigenDA nodes, we were able to already achieve a throughput of 1.4 megabytes per second of bandwidth. Since, of course, data availability is an embarrassingly parallel problem, this throughput should increase as you add more machines, and so we're actually really excited about the performance already. So that's pretty nice. What does it all look like together? This is kind of a little depiction of our testnet. We're working hard on a decentralized sequencer. We have our EigenDA nodes in the middle. We have our L2 full nodes on the right. And I wanted to just go through the life cycle of a block, which in the L2 case starts with a bundle of transactions. First, we achieve consensus in the sequencer on that transaction bundle. With that, we get a sequencer certificate. Next, this sequencer has to write these transactions and the sequencer certificate to data to be stored with the data availability layer, and we do that by writing to this dispenser. And this dispenser uses the Reed-Solomon erasure encoding and splits up the data and disperses it out to all of the different EigenDA nodes, which then respond back with signatures that gets aggregated into an EigenDA certificate and a blob key. The blob key basically is, you can think of it as the pointer to this data. Next, the disperser writes the EigenDA certificate to the L1 and then shares the blob key with the sequencer. After that, the blob key is written to the L1 in order to effectively finalize these transactions using the L1. And then from that point on, any full node deriving these transactions or these blocks can simply download the certificate, download the blob key, use the blob key to fetch the data. That gets them the transactions and the sequencer certificate. They can verify the sequencer certificate and then execute the transactions, and then that's how you get the derived L2 block. Pretty simple, right? So people have been asking what are the differences from proto-dank sharding, and as far as I can tell, these are some of them. The first difference is bandwidth. Proto-dank sharding, as of the latest numbers that I've heard from the Ethereum Foundation, is targeting 32 kilobytes per second. Dank sharding is targeting 1.3 megabytes per second. And EigenDA, from what we've been told, is already targeting beyond that, 3 to 10 megabytes per second. And I think the primary reason why they can accomplish this, and I'm sure Sriram can share a lot more to this, is the fact that they're using direct connections between nodes, which is pretty cool. Of course, Ethereum uses P2P, P2P network topology, but if you're willing to share your IP addresses with other nodes, then you can do direct connections, which it just becomes much more efficient from a bandwidth perspective. So we're pretty excited about that. Data publishing, from what we can tell, is the same. The other thing that we really like as a L1 transitioning to an L2 is that EigenDA is slated to support payment with multiple currencies. This is very valuable for any L1 that has a native token today, and something that's definitely very appealing for us. I think the support for both on-demand and prepayment is another interesting, I think, unique feature, which is also pretty cool. But the thing that everyone talks about, the thing that everyone is curious about is, what is the security like? How does it compare? And as far as I can tell, these are the main differences. In terms of nodes, depending on how you count how many Ethereum nodes there are, it could be tens of thousands or hundreds of thousands of nodes, and certainly proto-dank sharding and dank sharding is offering that. From what we've heard, it looks like EigenDA will offer initially hundreds of nodes and eventually tens of thousands of nodes as well. And so that's pretty cool. And then the security model offered by EigenDA means that it's actually a combination of these nodes and your decentralized sequencer nodes running your L2. So it's the combination of both of these. Proof of custody, we've heard, is planned, which is really nice for solving the lazy data availability node problem, which is also something that is being rolled out as part of dank sharding. And then finally, probably the biggest difference really is around the case of a 51% attack. Now this is an attack that happens when 51% of all either Ethereum validators, in the case of dank sharding, or all eigenlayer EigenDA nodes, in the case of EigenDA, when 51% of those nodes decide to act maliciously. And at least from our perspective, this is a fairly unlikely situation that, I think in the case of Celo, we're comfortable assuming will never happen. And so those are the big differences. I have I just gave a talk in L2 days where I really went a lot deeper into some of these differences, showing a whole bunch of block graphs that show exactly what happens in the case of a 51% attack in the dank sharding case. And so if you're curious about this, come talk to me afterwards. It's really quite fascinating because it's very complicated. Cool. Finishing thoughts. We're super stoked. I think EigenDA offers an extra tool in the data availability toolset for many L2s, and we're really excited for it. Ultimately, though, of course, Ethereum DA will be, the only data availability offering in the Ethereum ecosystem that can handle all sorts of attacks, including that 51% attack. But this trade-off is one that, we expect some L2s might be willing to take in exchange for kind of a cheaper data availability cost. So yeah, that's everything I have. Thank you so much. And this last emoji is let's go compete against Tron.